This is question 28 on the spring semester exam review. These are adding or subtracting polynomials. We have 3x squared minus 7x plus 12, and then we're adding to that x squared plus 8x minus 1. So when you're doing something like this, you want to look at the like terms. Now, since we're adding everything, it's almost like you could rewrite this, and you could write this a polynomial below this one and turn it into like a elementary school type adding problem where they're actually listed up and down and you add your columns together. So my x squared belongs in the same group as the 3x squared, so I write them there. My 8x belongs in the same group as my negative 7x. Okay, and my negative 1 belongs in the same group as my 12. So it's just basically adding down the columns. Now some of the adding is actually subtracting, as you see by the signs. 12 minus 1 is 11. The negative 7 and the positive 8, that's 8x minus 7x, gives me 1x, which we can just write as x. Notice the 11 I wrote was positive. When I first wrote it, I didn't have to put the plus, but now that I'm dealing with a polynomial situation, I need to put the plus between those guys. And now I have 3x squared and another x squared that's like a 1x squared. 3 plus 1 is 4x squared. So when I combine all the stuff, I end up with 4x squared, but I gotta add my plus sign here again. 4x squared plus x plus 11. So that's number 28. Let's take a look at 29. 29 is a little bit different. It's subtraction. That means we're taking away the x squared, we're taking away the negative 5x, and we're taking away the 2. The easiest way to take care of that in one step is you flip all the signs in here. You think of it as distributing a negative sign into all here, like multiplying all these terms by a negative 1. So I'm going to rewrite this. That negative 1 times x squared is negative x squared. And then negative 1 times negative 5x is positive 5x. Negative 1 times positive 2 is negative 2. So the result you get is you flipped all the signs. Okay? Now once I've flipped all the signs, it becomes an addition problem just like this one. It becomes a combining, just a regular combining problem. So I'm going to go ahead and write this one and line up the columns again. Okay, it doesn't matter which one's on top or on bottom. I'm going to put the 2x squared below my negative x squared. Okay, my negative 5x below my 5x. And my positive 13 below my negative 2. So let's combine these. That's 13 minus 2. Gives me 11. And then 5x and a minus 5x or negative 5x, they cancel out to nothing. I have nothing here. And then 2x squared minus x squared gives me 1x squared, which I can just write as x squared. Now since that 11 is positive, I put a plus sign in the middle. So number 29 is x squared plus 11. All right, let's take a look at 30. One rectangle has an area of 14x squared minus 7x plus 18 feet squared. Now, I want to point out while I'm reading this, the feet squared, that too has nothing to do with the math. That's just talking about that this is dimensions of a rectangle, okay? So don't get confused by that number. A second rectangle has an area of 6x squared plus 3x minus 2 feet squared. Again, we're not dealing with that squared from the feet squared. How many more square feet is the first rectangle? Okay, well let's turn this into an easy problem to help us understand what's going on here. If I said the first rectangle was 10 square feet, the second rectangle was 7 square feet, how much bigger is the first rectangle? How many more square feet is the first rectangle? It would be 10 minus 7, right? It's the same action that we're doing with these, except we're dealing with, more algebra, okay? The reason I turned it into a simpler problem is to help myself remember what type of math am I doing. It's just subtraction. Since it's subtraction, it's a lot like number 29, where I have to flip the signs of the smaller one, and then I combine. Okay? So they're saying how many more square feet is the first rectangle? They're saying the first rectangle is bigger, so we're taking away the second from it. So this is the one that has where we have to flip the signs. We distribute a negative here, here, and here. That gives us negative 6x squared minus 3x plus 2. Okay, so I flipped all my signs. Now I can just combine my terms pretty easily. Okay, so I'm going to go ahead and write the first one, 14x squared minus 7x plus 18. And I've already flipped the signs. I'm going to go ahead and write the like terms below each section. Okay, 18 plus 2 is 20. Negative 7x and negative 3x gives me negative 10x. I put a plus sign here between them because the 20 is positive. 14x squared minus 6x squared is going to give me 8x squared. That's it. My answer is 8x squared minus 10x plus 20 square feet. And that was number 30. That's it. Number 31 through 33 is a different section. All it's asking about is what is the name and degree of each polynomial. Now remember, poly means many. So we're talking about these are many little sections of math all combined together with plus or minus signs. That's how you know how many sections you have, by how many plus or minus signs. I'll be more specific here. They're separated by plus or minus signs. So there's a section, that's 1. There's the second section. There's the last section. Okay, so this is 3 distinct sections. That's called a trinomial. So number 31 is a trinomial. And what degree is it set to? When you're dealing with more than one monomial, you're dealing with several sections, you look at the exponent of the biggest section, and that determines your degree. So the biggest exponent is 4, so that is the 4th degree. We call that a 4th degree trinomial. 4th degree trinomial. Okay, now 32 is a little bit different. You don't see any plus or minus signs. So this is a monomial. Okay, it's all 1. When you have a monomial, you actually have to add together all the exponents. So you have x to the 3rd, y to the 6th, and z to the 1. Okay, 6 plus 3 plus 1 is going to give you 10. So we call that a 10th degree monomial. Okay, 33 is you have a plus sign in the middle, so that cuts this into 2 distinct sections. That's a binomial, bi for 2. Okay, so we have a binomial. You look at the biggest exponent in the whole thing, it's 7. So we call that a 7th degree binomial. There you go. Okay, we will move to the next video to go to the next section.